Hi everybody, I'm the documentarist and today I'm here on the Isle of Arran to do fieldwork, and I thought that whilst I was here I'd show you actually what it's like to be a geologist in the field and how we record our data. Because whilst usually I'm talking about the rocks and I talk about the environments that are going on here, I don't actually explain how we understand what's going on as geologists. And so today I thought I'd actually show you how we find out how these environments are changing from the rocks. Now, the first thing that's really important to do in the field is to actually record down some of the stuff that's going on around the day, not just the rocks like the ones you see behind me. So for example, I like to record the weather and my mood because often your mood can reflect your recordings and it may interrupt your recording, such as if you're in a bad mood. We also like to record our location and the grid reference and a risk assessment so we know how to stay safe in the field. Now, when you're recording your actual rocks, you like to do things like sketches like this, because often you can come back to those sketches and compare them with other rock sketches you've done of similar rocks. And this allows you to actually see if you've got a new bed or just a similar one to the one you had before. Now, what actually is it that we record in these books other than sketches and a general overview of the area? Well, that's where we turn to these rocks. Now, before you actually get up close and personal with the rock and identify what it is, we first want to mark on the extent of the boundary. Now, our bed of rocks starts here, and I like to walk along and see just how far it stretches. And it doesn't stretch too far. Over there we've got another boundary that is dipping the same way as these beds, which just tells us that there's no intrusions around or anything that is discordant or cross-cutting to our bed right here. Now, in order to actually identify the rock you have here in the field, you want to get up close and personal with the rock using a hand lens. Now, this is a type of magnifying glass that zooms in 10 times on the rock and shows you very small details. Then what you want to do is use a piece of equipment called a grain size card. Now, these tells you different things such as the roundness of your grains, the sorting of your grains, which tells you just how similar each grain is to each other, and the actual size here. And these are all things that we want to record in our yellow book. Now, you'll notice immediately from the grain size cards that our grains here are over 2 millimeters, as they are larger than these white dots right here. So we actually might want to use our chart at the top to measure them. Now, you'll notice, for example, this one right here is about 5 or 7 millimeters, whereas this one is about 15 centimeters. You'll also notice from the chart that we've got a pretty poorly sorted amount of clasts here, and on average they're about angular or sub-rounded. Now, the next thing we want to do is identify what our clasts are made of. Now, this first clast right here, it doesn't get scratched by a fingernail, and you can see that the way it breaks is very uneven, or as we would sometimes call this, conchoidal, which tells us that this is probably a quartz. Now, I've also tested this with acid and it doesn't react, which helps further solidify the idea that this is quartz. Now, this bit right here is very fine grained and is quite layered, but also a bit of a greenish or greyish colour, and this is a phyllite. Now, there's another grain around here. I can't find one, give me a minute. There's also this component right here, which is more of a red colour, but white with black streaks inside. And you'll notice, in the same way to quartz, it doesn't scratch when you scratch it with a fingernail, and it's also not reactive. And this is a metaquartzite. And in this specific rock, these components are actually about an equal abundance. We often use the term abundance to describe how much of each clast is in the rock, and there are fairly equal parts of each bit of clast in this particular bit of rock, although later on down the beach there seems to be more of an abundance of vein quartz, this stuff right here. And once you've established your clasts, you want to do a little sketch just to make note of what you've actually seen here. And now what we want to do is actually find out the angle at which our beds are dipping, and to do this we use a very nifty piece of equipment called the compass chronometer. Definitely my favourite piece of equipment. Now, we first want to find the dip, so what we like to do is find a nice bedding plane to take this on. Usually I take it straight on the plane, but because breccia is so angular, I'm going to be taking it on my mapping board, and we'll turn the compass chronometer to east so that our chronometer section isn't on an angle. And then you just want to place your compass chronometer against the board and take a reading. So here it's reading for me 36, so our beds are dipping 36 degrees. Then we turn it perpendicular to our dip and horizontal so that we can take the strike. Now, there's 2 red arrows on top of our compass chronometer here, and you just want to turn those to be aligned with each other. And that reads for me a strike of 198. Now, the reason we take the strike is actually so we can mark things on the map. So I pulled up my map here so far. You'll notice I've already got quite a bit on it. And actually what we want to do is draw on this breccia bed and the difference between the breccia and the new bed, which is a conglomerate and sandstone. So I've got here on my compass chronometer my breccia strike. And what you want to do is align these northing arrows here with your northings at the top. And then just take your chronometer to where I've marked on that the breccia beds end, and you draw a line, and that marks on your geological boundary right there. And then what you can also do with this strike is you can then mark on next to it a tick right here. Oops, don't do that. Right here, and mark on a tick sign next to it and a measurement of the dip, and that's all your dip and strike information right there next to your bed on the map. Another thing that we like to do as geologists is not just finding boundaries but actually inferring them between other boundaries. Now behind me here you can see a rock face, and this is a conglomerate that I've found. Now, earlier on, around the beach over there, I've also found the same conglomerate boundary, and what we can actually do is find these two boundaries and link them together as one inferred boundary. And actually, doing this is actually very easy, because as you'll see here, this is where I originally found that conglomerate, and then here's where I found it again, and just between these two lines you can draw a little dotted line to produce one full boundary right here. There's a couple other ways us geologists like to process data, and one of the ways is through something called a sedimentary lock. This goes through some very small sections of beds, this one's only up to 2 meters, to look more finely at the details between beds, and often it can tell us about the environments. For example, this sedimentary log here that I took goes between sandstone to mudstone to sandstone to mudstone, often showing things such as rootlets, which indicate a terrestrial environment here, or symmetrical ripple marks up here, which indicate a marine environment, and asymmetrical ones here, which indicate fluvial, which shows us that there were changes in the environment over time, which deposited different beds of rock. And whilst these logs only record things on a small scale, they're incredibly important for our future. For example, if a mass extinction happened, these logs often tell us the events leading up to that mass extinction or what the climate was like at the time, and we can often use this to predict what climate change will hold for us, and how it may impact our environment, and if we're even driving ourselves into our own mass extinction. Plus, it can be important for helping us understand theories such as continental drift, as changes in rock type over environment tell us that we may have moved over time. For example, you get a desert sandstone followed by a tropical marine limestone or sandstone. This tells us that the environment may have changed from an equatorial environment where you get a dry desert to a tropical environment around 30 degrees of the equator. Now, another fun thing we can do as geologists is called generalised vertical sections and cross sections, and these can actually cut into our Earth like a cake and show us actually what's going on inside. Now, I'm going to be using the example of my Corrie map here, as it's a lot more simple than the Sanix map. And actually, when we draw across the line and follow the dips that we took earlier, we can produce something that looks like this, or like this. And as you'll see, you can see all the beds dipping in the direction that I recorded earlier. And then we can use a bunch of fun calculations to calculate our true thicknesses, as when you look at a bed, you're only looking at the apparent thickness and not the true thickness. So when we look at the true thickness, we can compare the thicknesses of different beds to each other to see which ones are thicker and thinner. Now, of course, there's a lot more that geologists do in the field, but I really just wanted to give you a slice of what I do as a geology student whilst I'm out doing fieldwork. With that being said, thank you so much for watching this short little video, and I really hope to see you again in another one. Testing the volume of my videos. Oh look, it's a dead seagull. Oh, get in frame. Now, as geologists, it's incredibly important that we get everything down on pen and paper as we're recording things, because this means we can come back to it later. a grid reference, which I'm going to do later, and the date, as well as a risk assessment, because what if we trip and fall and die? That's not how we frame. Now our bed starts here, and as we walk along it, oh, there's a book over here! Paint me like one of your French girls. The rock, for example, it's upside down. Now, as you can see, it's got a lot of different things on it. This one's from the University of Leeds. I don't go there. They just did a talk. And this is not sponsored by the University of Leeds. I'm sure you guys are lovely, but not my uni. Now, if you look at the rock here, you'll immediately notice that these grains in the rock are actually larger than our usual granite I've dropped. Now, the next thing we want to measure is the angle at which the dips are bedding. I'm just trying to work on the rocks here and I'm being assaulted by insects. I look like a twit because I've just gotten out the shower, but I need to hand in all my work in like 3 hours and I need to show you guys some of the other things that us geologists do, so just gonna have to roll with it. Fun thing we can do as geologists are cross sections and generalised vertical sections. Stratigraphies? Sections? Do you guys think I brought enough rocks back?